with our equation from the last video clip that we proved and we got this equation. So now we will train it using the previous example in the previous video clip like this. So at first we've used numpy as np, and then we'll create an x first. X to be the array of, in this case we have we have the vector like this. X will be, the first one is 1 and 1. The second one is x0 is 1 and 3, 1 and 5, and 1 and 8. This one is the x vector, right? In our previous example, you'll see that I think you can still remember that we train it using x. This one, uh, we use x to be 1, 3, 5, and 8, right? But this one is x1. You can imagine that this one is x1, and of course x0 will be 0, 1, 1, 1, and 1, right? So you will have the vector x to be 1, 1, like this, to be a moment. This one. So the first x will be a moment. I would like to move x0 back here. Okay. Okay, so guys, we have first vector to be 1, 1, right? The second one is 1, 3, 1, 5, and 1, 8. So there are four inputs. Okay, so I arrange x to be the data like this. Okay, now I have to start with the blue. So the blue is like a weight that can be generated from np.random, and I provided like one row, 2 columns. So you will get the blue weight of the blue to be these values, 1 row, 2 columns, like this. So now we have 4x, right? We have 4x. So x0 will be 1, 1. Can you see? X1 will be 1, 3. Okay. X2 will be 1, 5 here. And the last x3 will be 1, 8. So let's check this one. Okay, so guys, if you want to use the blue.x, but you have to transpose x also. Oh, okay. So it's like now it's like you use these values and dot with 1, 8. So it is you have to times this term 8 to 0 0.9, so it will be 7.2 plus this values, so plus this one. Okay, so you can try to dots with x0 also. To dot with x0 is like you can like sum it together. Okay, so now we have the equation of the blue.x already, and we have to declare the target also. The target can be it is so our solution is minus, our solution is minus 1.7 plus 2.4 x1. Our output. So this is our solution. So it's like the target one. So this is the target one. So it is minus 1.7 and 2.4 times x. Let's check the result. If this is correct or not. Oh, okay. I'll use axis is 0. Okay, so now we got the target already. We can calculate using this equation, using this statement, using NP sum, using NP sum, and provide the solution, our target one, our target solution. So guys, now we have target, we have W, starting W, and we have X. So now we are ready to train it. I'll delete first. Okay, so I will use the loop for I in range number of iteration, like if I start with 1000, and for each data, so we have 4 of x, right? So we use 4 to be values of x here, and guys, the output can be calculated by w dot xj, right, this is output, this is output, this is xj. Okay, just check. Oh, it's quite like too, because it will range like we call the epoch, because this one epoch means that we will iterate through all training data. So in our case, the training data, we have 4 training data. So when we have 4 training data, it means that in one epoch means that we have to train it using 4 iterations. This is a 4 iteration for all data here. So this one is the output, comes from w.x for each x. So now our target, we will have target j minus, let's check this one. Our solution, w is w plus eta target minus output times x. So our weight will be weight plus eta. In this case, I will set it to be minus 0.1, or you can set eta to be 0.1 here, and then use eta here, times target. Target is target of j minus output and times xj. So for the first epoch with 4 iterations, you will see how our width change. Here, Our starting weight is here 0 0.8, 0 0.9, and it will change to these values, these values, these values, and these values. Okay, so so now so you can see that our weight is already changed. So let's check that. For example, if it move like 10 epochs, so it will have 40 iterations. So this is the how our weight change. So you can see that in some part it's like because our values here, our values here is like the values of x is like very high. So our weight is like when you train it, it will like not convert. It's like it diverge. It's diverge to like not a good one. So you can adjust the values by using a little bit slower of learning rate. So now your weight is adjust like slower, slower and slower. So now you can try to make it like you can try to make it like now this time 1000 epoch. So in each epoch you have 4 iterations. So now we have 4000 iterations. So what can we get here is, can you see? I will. So now it's converged to minus 1.7 to and 2.4. That is our solution, right? Wow. So now it means that we can train the linear node. But sometimes you can think that, oh, if we change this learning rate to be 1, the problem is it, can you see? It's diverge because the last one, our last term, our x is quite high in this case. So many people would like to just like, if the size of x is very high, you can change or you can reduce it using the like divided by the size, that is 1 plus xj I square. This is like you can divide it by the size of like 1 square plus 8 square, something like that. Okay, so let's check. Oh, I forgot to import the map one, so I will import map first here and run it again. I'm sorry, we have to start with small w again. I'm very sorry. So now it's already changed. Ha, 4 3 2 5 4 3 2. So when you divide it by the size of the vector, so this term will be, sorry, this term will be the unit vector. So now we can change the error rate back to 0 0.1 because now for each term the x values will be like not use 8 anymore, but use the unit vector of 1 8 instead of 1 8. We use the unit vector of 1 8 instead. Okay, so I hope that you can see this is an example of how can we train the linear node. So guys, I hope you enjoy how can we find the training equation and how can we apply that training equation with the real example. Hope you enjoy it.